The most impossible water trade in human history.
An iceberg the size of an entire city.
A giant mass of ice weighing more than 100 million tons.
Something that would have to be dragged across more than 10,000 kilometers of open ocean.
A trade operation so massive that it doesn't just seem difficult, it seems impossible.
And yet, there are people who seriously want to make it happen.
The United Arab Emirates is considered one of the richest countries in the world.
It is home to some of the most impressive achievements of modern civilization.
Every year, millions of tourists visit the UAE.
It has the world's tallest building, the Burj Khalifa.
World-class artificial islands, luxury cities, massive trade ports, and a trillion-dollar oil economy.
All of these factors have helped turn the UAE into one of the most powerful countries in the Middle East.
But behind all of this wealth and power lies a problem that continues to grow every year.
A problem that quietly threatens the country's future.
Water.
The UAE receives only about 100 millimeters of rainfall annually. As a result, the country spends billions of dollars every year to secure its water supply.
It operates some of the world's largest desalination plants to convert seawater into fresh water.
It has invested in cloud seeding projects to create artificial rainfall.
And various foreign water pipeline proposals have also been discussed over the years.
However, among all these solutions, one idea stood out and shocked people around the world.
The idea was simple in theory, but extraordinary in practice.
Import a giant iceberg from Antarctica to the UAE.
And if it ever becomes reality, it could become the largest and most unbelievable water import project in human history.
And then, one man came up with an idea that didn't just shock the water industry. It shocked the entire world. His name is Nick Sloan, a South African salvage expert, a man whose entire career was built around doing things that everyone else called impossible. He's the same man who helped raise the Costa Concordia, a 114,000-ton cruise ship that capsized off the Italian coast. If anyone was going to look at a floating mountain of ice in Antarctica and say, I can move that, it was going to be someone exactly like Nick Sloan. And the idea didn't come from desperation, it came from logic.
Nick looked at the UAE, one of the driest countries on Earth, and then he looked at Antarctica,
a continent holding 60% of the world's entire freshwater supply locked inside ice.
Two extremes, one with too much, one with almost nothing. And between them, just ocean, just distance, just engineering, just money. That's a trade waiting to happen.
But before we call this completely insane, here's something that will surprise you. This isn't the first time the world has thought about moving icebergs. Most people assume iceberg importing is a brand new, half-crazy idea born in the 21st century. It isn't. The concept of iceberg towing goes back to the 1970s. During the oil crisis and global water shortages,
Engineers and governments weren't just thinking about oil pipelines and desalination. They were seriously drawing up plans to drag icebergs across oceans. Saudi Arabia explored the idea in the 1970s. Prince Mohammed Al Faisal even funded early research into towing icebergs from Antarctica toward the Arabian Peninsula.
a formal international conference was held, the Iceberg Utilization Conference of 1977.
Where scientists, engineers, and investors gathered to ask one serious question. Can we actually trade in frozen water? France conducted studies on towing icebergs to quench the thirst of drought-ridden regions in Africa and the Middle East. Australia looked into it for its own dry interior. Even parts of South America explored the concept for agricultural use. Every single time, the idea hit the same wall. Not imagination, not money. The wall was the ocean itself.
Selecting the right iceberg is a trade operation in itself. You can't just pick any iceberg. It needs to be the right shape, flat-topped, wide, and stable. It needs to be large enough that even after melting, it still delivers enough fresh water to justify the cost. Nick Sloan's team calculated they would need an iceberg approximately 100 million tons in size. Mass! That's not a block of ice. That's a geological structure. Finding that iceberg, surveying it, and attaching towing equipment to it is already a multi-million-dollar operation before the journey even begins. The distance from Antarctica to the UAE is roughly 10,000 kilometers, dragging a floating mountain through two of the world's most unpredictable oceans, at a speed of roughly 1 to 2 kilometers per hour, because that's all you can manage when your cargo weighs 100 million tons. The journey would take approximately 8 to 10 months. In those 10 months, the iceberg is melting every single day. Every single hour. This is the trade's most terrifying risk. Iceberg melt loss. Current projections suggest that by the time an iceberg reaches the warm waters near the UAE, It could have lost anywhere between 20% to 30% of its original mass. On a 100 million ton iceberg, that means you're
losing 20 to 30 million tons of fresh water simply melting into the ocean before you've extracted a single drop.
Counter this, engineers have designed something extraordinary: insulating skirts. Giant fabric wraps, essentially enormous blankets that would be draped around
the submerged sides of the iceberg to slow down heat transfer from the surrounding warm ocean water. It sounds almost
absurd, but the math supports it. Sloan's team claims these skirts could reduce melt loss dramatically, potentially keeping overall loss
to 20%. But here's the next question nobody talks about enough.
What happens if the iceberg breaks?
An iceberg is not a solid, uniform block of ice. It is a fractured, stressed, ancient structure that has been under pressure for thousands of years. Underwater currents, temperature changes, wave action, any of these can trigger what's called calving, when a massive chunk of the iceberg suddenly splits and breaks away. Now imagine that happening mid-ocean, mid-journey. Your 100 million ton trade asset suddenly becomes two pieces. The towing cables attached to specific points on the iceberg are now pulling unevenly. The broken section begins drifting. You're in the open ocean with fragmented ice and a towing operation that is already pushing the absolute limits of marine engineering. Do you abandon the broken section? Do you try to secure? Do you continue with what remains? Every answer costs money, every hour costs money, and the clock on melt is still ticking. This is a trade with no pause button. Let's say the impossible happens. The iceberg survives the Southern Ocean. It survives the Indian Ocean's warming waters. It arrives massive, scarred, partially melted off the coast of Fujairah on the UAE's eastern shoreline. Now what? You can't dock it? No port in the world is built for a 100 million ton ice structure. You can't lift it, you can't truck it. What you do instead is mine it. See, the plan involves establishing a floating extraction operation directly beside the iceberg. Specialized equipment would grind and cut sections of ice. That ice would then be melted on site into liquid fresh water, and that fresh water, billions of liters of it, would be pumped through underwater pipelines directly to onshore storage and treatment facilities. The extraction itself could take months. But the yield, if the iceberg arrives intact enough, could be staggering. Nick Sloan's team has run the numbers. And the numbers are the reason this project refuses to die. A 100 million ton iceberg contains approximately 20 billion gallons of water. That is enough to supply around 20% of the UAE's annual water needs for an entire year. From a single iceberg, a single trade. Now compare that to desalination. The UAE currently operates some of the largest desalination plants on Earth. These plants consume enormous amounts of energy, almost entirely from fossil fuels, to strip salt from seawater. The process is expensive, energy intensive, and produces a highly toxic byproduct called brine, which is pumped back into the sea and damages marine ecosystems. The estimated cost to tow, insulate, and extract water from a single Antarctic iceberg, approximately $80 to $150 million USD for the entire operation. The cost to produce an equivalent volume of water through desalination, significantly higher when energy costs, infrastructure, and environmental remediation are factored in. This isn't just an engineering project. This is a cheaper, cleaner water import that could reshape how the UAE and every water-scarce nation thinks about its supply chain.
Here is a dimension of this trade that almost nobody discusses publicly.
If a 100 million ton iceberg is anchored off the UAE's coast for months during extraction, what happens to the surrounding water temperature? Ice cools everything around it.
A mass that large could lower local sea surface temperatures in the immediate area.
That means cooler air above the water. That means changes in humidity patterns along the UAE's coastline. Some researchers believe this could potentially increase rainfall probability in an already cloud-seeded environment.
In other words, the iceberg trade doesn't just deliver water, it might actually slightly alter the microclimate.
The region it arrives in, for a country that spends hundreds of millions annually on cloud seeding programs to generate artificial rain, that secondary effect alone is worth studying.
It transforms this trade from a one-time water import into something with compounding environmental returns.
Projects this ambitious usually die in boardrooms. They get filed under interesting but impractical and forgotten. This one hasn't. In 2017, the National Advisor Bureau Limited of the UAE announced it was actively
pursuing iceberg towing as a real water solution, not a theoretical one.
Feasibility studies were commissioned, marine route simulations were run, engineering firms were engaged. In 2019, a computational fluid dynamics simulation conducted by Sloan's team using real ocean current data Real temperature gradients and real iceberg geometries showed that towing a large, flat-topped iceberg from Antarctica
To Fujairah was physically achievable.
Not easy, not cheap, but achievable. The simulation mapped the optimal towing route, southward from Antarctica, then northward through the Indian Ocean,
Carefully avoiding the most heat-intensive equatorial waters for as long as possible, before turning toward the
UAE coast in a trajectory designed to minimize melt exposure. Every objection that engineers raised,
The simulations answered with data. The Southern Ocean storms? Solvable with seasonal departure timing, leaving Antarctica.
during the southern hemisphere's late summer, when storm activity is at its annual low. The melt problem? Partially solvable with the insulating skirt technology. The calving risk? Manageable with real-time structural monitoring systems.
Embedded in the ice. This trade is not science fiction dressed up as news.
It is a serious logistical and financial calculation that a wealthy, water-desperate nation is genuinely weighing.